Hi everyone, welcome back to this video, and in this video I would be giving you some example on stratified sampling, which is a type of probability sampling. I've taken a lot of videos on sampling and the different types of sampling, so if you haven't got to see those videos, you can click on the links given in the description box, and without any further delay, let's get into this. So unlike the other videos, I'm going to start off with an example and then I'm going to give you the definition of what is stratified sampling. So here to start off with an example, there's a researcher, okay, and he wants to conduct a research to find out how many students get an internship within the first 2 months after their studies over the period of the past 5 years. So this is this researcher, he's sitting there and wondering what can be done, and then this is his entire aim and goal to do. So as you see, there are graduates over here, and then you need to understand how many get internships in the first 2 years after their graduation. So on the analysis, the researcher creates a strata. Okay, so strata is nothing but a group of entities, or I can say a group of whatever you can call. It's a group of some entities or objects that have some similar, not some, they are definitely similar, okay, to each other. They have common characteristics and attributes. So let's say you have this population of all the students for the past 5 years who have been graduated. So the researcher starts creating groups of similarities, and those groups are called as stratas. So, among the entire population of students who have graduated over 5 years, the researcher created two groups which are stratas. One is the science group and the other one is the arts group. So, you have two stratas of the students from the science departments and the students of the arts department. So, keep in mind these two are called stratas. So one thing to keep in mind, so if you would have seen any probability or sampling or any video or any blog or any site, usually a sample, that's the key rule, it says that the sample should be a representation of the population. So now when you understand your sample and when you understand the population, you would come to know what is the composition of your population. That is, your population would consist of different people or different objects or different entities. You must understand to what percentage, what type of characteristics or percentage of people exist. So now when you're doing this analysis, the researcher understands and comes to know that there is 60% of students who have graduated from science degrees and 40% of students graduates who have graduated from the arts degree. So this is your composition. So now after getting this composition of all the students and dividing them into stratas, what this researcher does is he applies stratified sampling. So now you have the science strata of 60% of students, and then you have the art strata of 40% of students. So now on applying random sampling, so after you have created stratified groups, okay, they are stratas, you apply random sampling and you would get a sample. So when I apply random sampling, depending on my ratios, so out of 60%, the researcher choose to select 6 students from the science strata and 4 students from the art strata, since it's a 40-60% ratio, okay, or maybe 60-40 ratio. So based on that, this is the sample that is obtained. So you have 6 of the science students because of 60% and 4 because of the 40%. So now you get a sample, and when you look at the sample, definitely it's a representation of the stratas. That's your whole population. Okay, so the ratios match, the people from each strata match, and therefore it's a representation. Okay, so 6 and 4, which gives you your sample. So this is a gist of what is stratified random sampling. And one thing you need to notice is you had your population, you just divided or categorized or organized your population. There was no one who was eliminated from this strata, okay? So definitely your entire population exists in this strata, and when random sampling exists to the stratas, everyone in the population have an equal chance of being selected. That's why stratified sampling is a technique which is related to probability sampling, where every observation, so people in the population, they are called as observations. So every observation have an equal chance of being selected. So even when you look at this particular procedure, every student had an equal chance of being selected. And not only here with this, like there's one sample that's being generated, you can create number of samples. So this can be your first sample. Again, you can do a random sampling where another six people from here and another four people from the next strata can be got. So you get different samples where every time everyone has an equal chance of being selected. So this is about the stratified random sampling. And it's not just that you have to create high level categories. You can apply number of criterias to your stratas and generate a strata. For example, you have the science stratas. Now within the science strata, you might want to divide the group into the science male female group. So you have all the males and females, and then you have the arts males and females. So even you can do your analysis to the extent of the number of male science students being getting placed after 2 months, the number of female science students, male arts, female arts, you can go to that level. So that's the advantage of using this stratified random sampling. And another thing to note is within a strata, all the observations or elements, they are homogeneous, because as I said, each one has similar characteristics and no one is different in a strata. This is totally you know um, opposite to the cluster sample where everyone in the population are of different varieties. So make sure in stratified stratas, with the elements within a strata, they are similar to each other, and when it's comparing to another strata, they differ. So it's homogeneous within and heterogeneous outside. So now let's get into the definition of what is stratified random sampling, and definitely be easy to relate to. So there you go. So stratified sampling, it's a probability sampling technique where the entire population is divided into smaller subgroups known as stratas, and samples are selected from the strata using random sampling technique. Very easy to understand with the example. The next one is stratas are homogeneous inside and heterogeneous outside, which is, this is what I told you. Homogeneous inside, heterogeneous outside a group. And stratas are formed a group based on similar characteristics of the population. So yes, all are similar within a strata. And then the last one, when you can use the stratified random sampling. So it's best when trying to evaluate data from different subgroups or stratas. Now you need to understand certain, information of, from different subgroups or stratas based on some criterias. Maybe you're doing an analysis on only art students, only science students, within science only medical students, or only engineering students, or otherwise people based on a particular salary range. It can be anything, okay? So when it comes to dealing with different subgroups or stratas, you can go in for this sampling technique. And the final one is, it best represents the entire population being studied. So when you look at the population being studied, you're focusing on a particular population that's relevant to your study, okay? um, the ratios are also managed. Everything is best represented in this particular technique. So this is about stratified sampling technique. If you like this video, you found it informative, please do give this a thumbs up. If you haven't subscribed to this channel, please do subscribe to this channel, and also do share your feedbacks. Thank you.